When we talk about our solar system, what is it? Well, we're going to look at a general overview of what is in our solar system and some of the characteristics of the things found there. So first off, as far as what is in our solar system includes our sun, which we see right here, the planets, which are pictured here. And what you don't see in this image are the moons, which go around the planets, asteroids, which orbit around the sun, comets, which orbit around the sun, and meteors, which are pieces of asteroid or comet that fall onto the Earth. The largest object in our solar system by far is our sun, and as you can see, 99.8% of the mass of our entire solar system is in the sun. And in this picture, you start to get a sense of why that is. So, as we saw, this giant thing here is our sun. And our planets. Jupiter is the biggest of the planets, and even it looks tiny compared to the sun. And then the planets just keep getting smaller, from Saturn, Uranus, and Neptune, and then all the other planets are in that little box, which some you can't even quite see. The two brighter dots are Venus and Earth, and then there are some very faint small dots in there for Mercury, Mars, and even Pluto is in there. So our sun is huge. That's why the planets orbit the sun and not the other way around. The first 4 planets are called the terrestrial planets, and the word terrestrial means Earth-like. So terra refers to Earth, and so terrestrial means planets that are like Earth. So our terrestrial planets, we've got down here Mercury, first planet that orbits the sun, then Venus, of course Earth, and Mars. So these 4 constitute the terrestrial planets. And the things that these 4 planets have in common, the reason why we group them together, are a couple things. One, they are all relatively close to the sun. Being the first 4 planets, obviously they are the 4 that are going to be closest, but even relatively speaking compared to Jupiter, the next one out after Mars, the terrestrial planets are much, much closer. So one of the effects of being close to the sun, they're going to be, again, relatively warm. Now, when we go into more detail about the individual planets, warm has a broad range of possibilities, from a high of 900 degrees Fahrenheit on Venus down to just barely being above freezing for Mars. The other characteristic that these have in common is that they are very small and low mass. Again, this is relatively speaking compared to the other planets. These 4 are much, much smaller than the Jovian planets. Being lower in mass also means less gravity. So these aren't going to influence things like comets nearly as much as the larger planets. And the last thing that these 3 have in common is a high density. And recall that density is one of the ways that we determine composition. And in this case, from the high density, what we know is that these are composed primarily of rock and metal. So these are our solid planets. Yeah, if you wanted to go out in your spaceship and wanted to land on a planet, these four you could definitely land on. Our next four planets are called Jovian, and Jovian means Jupiter-like. The word Jove refers to Jupiter. If you ever heard the expression by Jove, that refers to Jupiter. And so our Jovians, we've got Jupiter, Saturn, Uranus, and Neptune. And like the terrestrial planets, we lump these together because of similarities. These four, much farther from the Sun. Not even like the same spacing as the terrestrial planets, but even more spread out. And so the distances are even that much larger. And so these are going to be relatively cold planets. You're not going to be reaching temperatures above freezing out here. These are also by far much larger than the terrestrial planets. I don't have an image that shows a comparison, but Earth is the largest of the terrestrial planets, and the little shadow that you see on Jupiter here, that's not too far off from the size of Earth in comparison to Jupiter. So these things are much, much, much bigger than the terrestrial planets. These also have high mass. So these are going to have a lot of gravity. And one of the things we'll see is that large amount of gravity is going to give each of these planets a pretty good collection of moons because of things that they have captured that got too close. And then the other thing is their densities. All three of these have a low density. And so from that, we know that their composition is primarily hydrogen and helium. Now these two abbreviations are the chemical symbols. H stands for hydrogen, He stands for helium. And when we talk about Jovian planets, we're going to see those two symbols quite a bit. Pluto is no longer considered a planet. It's now considered a dwarf planet, largely because of its orbit and the fact that it shares its orbit. So it's actually in a belt of objects, similar to the asteroid belt, but out past Neptune is a belt of objects that are similar to comets. And Pluto is right in there with them, and that's why it lost its planet status. But Pluto has never really fit in. And when we look at the characteristics of Pluto compared to the terrestrials and Jovian planets, it's clear it doesn't fit. It's certainly the farthest of all the planets, and that's going to make it also the coldest of all the planets. It is very much the smallest. If you compared Pluto to the United States, Pluto is smaller than the United States. It's got very low mass, very low gravity. So it is one that just doesn't quite fit in to that category. And then the composition, the density, has a medium density. And from that, we have figured that its composition is a mixture of rock and ice, which is much more like a comet than like either the terrestrials or the Jovian planets. So between the composition being very different from everybody else, its size very different from everybody else, and now we know its orbit is in the middle of a belt of materials, Pluto just never fit in, and so it makes sense to no longer consider it a planet, but to give it a different category of a dwarf planet. Now the moons orbit around planets, and the definition I've given here, large objects that orbit planets. Large is again relative. These 4 moons that you see here are the largest moons of Jupiter, and the largest one here, Ganymede, is actually bigger than the planet Mercury. But it's considered a moon because it orbits Jupiter. It does not orbit the Sun. It's carried around the Sun as Jupiter orbits, but the center of Ganymede's orbit is a planet, and so it is considered a moon. Now, where these are the largest of the moons, down to the smallest of the moons can be as small as 10 miles across. So there's a wide range of possible sizes when it comes to moons. Rings I've defined as small particles that orbit planets. All 4 Jovian planets have rings. Now, of course, Saturn's ring system is the most famous, and that's because its rings are the brightest, the easiest to see. Now, they're composed primarily of ice, which is highly reflective. Jupiter, Uranus, and Neptune, their rings are dustier, they're darker, they're harder to see. And so it wasn't until much better photography was available, and in the case of Jupiter, it wasn't until we had a spacecraft fly out there that we knew that it had a ring. So much more difficult to see. But the rings are going to be collections of particles, much smaller. The moons, we said, down to about 10 miles. Here we're looking at objects kind of snowball, boulder size, something like that are orbiting around all 4 of the Jovian planets. Asteroids are what we would consider smaller objects, 10 to 20 miles across, something along those lines. So here we see Ida. That long axis is probably about 15 miles, maybe less. Same thing for Gaspra. Composition is rock and metal, and these orbit the Sun. Most are found in the region between Mars and Jupiter, and that's the region we call the asteroid belt. But there are others that are elsewhere. About 75% are in the asteroid belt, and the rest can be found pretty much anywhere else in the solar system. Because they're small, they are typically not round. They have these odd-looking shapes, and so sometimes they're described as looking like potatoes. They can have their own moons. Dactyl here actually orbits around Ida. And it was probably a little piece of Ida that got knocked off, but the gravity of Ida kept it in orbit. Remember, gravity just requires mass, and Ida, even though it is small, does have a mass, and so it does have a gravitational pull to keep Dactyl in its orbit. And comets are the last of our objects in the solar system. Again, these are small, similar in size to the asteroids. So again, we're looking at the kind of 10 to 20 mile range as a typical size. But notice that the composition is different, rock and ice. Also notice that's the same as the composition of Pluto. So there is some speculation that Pluto is actually a comet. It just stays so far from the sun that it doesn't develop the tail that we associate with comets. These orbit the sun. They are typically found farther away from the sun, out where Pluto is and beyond. And it's only if their orbit gets altered that they'll head in towards the sun and start to develop these tail that we see. Normally a comet doesn't have a tail. It's going to, under normal circumstances, look like an asteroid, but with this rock and ice mixture. And it's only when it gets exposed to the heat of the sun that the ice starts to evaporate. And when that happens, it develops all of this gassy material that we see as a tail. So those are the things we find in our solar system.